Hello everyone. In this tutorial, we are going to solve some of the linear algebra questions that are asked in the GATE examination in the previous year. So let's start. The first problem says all the entries of 2 cross 2 matrix where matrix is given in the form of P11, P12 and P21, P22 are non-zero. Okay, it is given that all are these entries are non-zero. Okay, and one of its eigenvalue is 0. Okay, we have given okay, it is given that one of the eigenvalue of this matrix is 0. So we can say that let's say lambda 1 is given and it is 0. Now they are asking which of the following statement is true. Okay, okay, so we have to use the property. We know that the multiplication of this both eigenvalue lambda 1 and lambda 2, it's given a determinant of that this matrix P. So let's find the determinant of this matrix. So we get P11 multiplied by P22 minus P12 minus P21 is equal to lambda 1 multiplied by lambda 2. But since we know lambda 1 is 0, so the determinant all is 0. So we can check from the option and say that option C is the corresponding correct statement. So option C is the correct for this problem. Okay, let's move to the next question. Okay, next question. And the question says the system of linear equation. Okay, we have given two equation. They are asking about the solution of these two equation. Okay, so let's write 4x plus 2y is equal to 7 and 2x plus y is equal to 6. Now you can see if you multiply this second equation by the 2, then what you get here 4 and here 2y, but the right hand side you get 12, but here it's 7. So left hand side of these two equations are getting equal, but right hand side will not. So you can directly say from this, looking this uh, left hand side and right hand side, the system has no solution. But let's derive it using the matrix. Okay, so 2 1, here the coefficient are 7 6. Now the apply some row operation. Let's what are we going is r2 minus r1 by 2. Now it's become our new r2. Now after that, after this transformation, what we get is here we get 0, here we get 0, here 6 minus 7 by 2. So from that you can say that the rank of the our matrix A is not equal to the rank of the our augmented matrix. So we can say the system has, sorry, you can say that the system has no solutions. Okay, so the correct option is the B. Okay, you can see here from the second row of the matrix. Here the equation you can write in the form of equation, linear equation. You get 0 x, not x1 only x, 0x plus 0y, but the right hand side will be not 0, it is become 5 by 2. So what are you getting is like this, and it's not true. Okay, it is not possible for any such values such that this equation will satisfy. Okay, so we can say that the system is inconsistent, or in other words, system have no solutions. Okay, let's move to the problem number 3. Okay, problem 3 says find the eigenvalues of the following matrix. Okay, for the finding of eigenvalue, we have to use this sorry, yeah, a minus lambda I is equal to 0, and from there you get the characteristic equation. equation of this matrix, and from there you can solve for lambdas, and from there you get the all the eigenvalues. But here in the MCQ type question, what we are going to do, we are simply use properties properties of eigenvalues. Now it is good alternative to use the property in this MCQ type of question for saving the time during the examination. So we know that the sum of the all the eigenvalues must be equal to trace of this matrix. So here, what is the trace? Here the trace of this matrix M, it's 3. So from checking option, we can delete option A because there is a uh, addition other than the 3. So option A is wrong answer. Option B, okay, option B we are also not getting. Sum is 3. In option C we are also not getting option 3. Okay, the remaining option is only D, and we can see we can get the sum equal 3. So option D is the correct. And now here the you can see the whenever the eigenvalues are coming in the complex, either in the form of A plus Bi, then they are must be in the pair. If A plus Bi is the eigenvalue of the any matrix, then A minus Bi is also the eigenvalue. It must be. Okay. So from the option you can see that in the option A there are the two imaginary number, but they are not complex conjugate of each other. So option A is uh, not the right choice. From option B you can see that the it is also not the correct answer. Okay, and option C you can also see because uh, there are the three complex number, and okay, these are actually complex. There is a mistake in typing. Okay, so you can see that option C is not the right answer. Now the remaining is option D, and you can see if 3 minus 1 plus 3i is the eigenvalue, then minus 1 minus 3i is also the eigenvalue. You can see in the option D that both are available. So option D is the correct one. Okay, let's move to the problem number 4. Okay, problem number 4 says uh, the system of equation. We have given three equation in terms of x, y, z, and they are asking about the values of this variable. There is two variable lambda and mu, such that the system has no solution. Okay, system has no solution. We have to find the values of lambda and mu such that the system has no solution. So first of all, let write the matrix. Here the coefficient matrix. Here coefficient is 1. Here 1. Here 1. Here is 6. Here is 1. Here 4. Here 6. Here 20. Here 1 for lambda, and here it's mu. Now what we are going to do, apply some row operation to reduce it into the echelon form. Here what we are going to apply first is let's subtract r1 from r2. It's become our new r2, and let's subtract r1 from r3, and sorry, it's 1. Let's become our new r3. So after that, what are we getting? Like, let's write matrix again. 1 1 1. The 6 is remain as it is. The here we get 1 minus 1 0. Here 4 minus 1 we are getting 3. Here 6 minus 1 5. Here 20 minus 6 we are getting 40 14 14. Here 1 minus 1 again 0. Here 4 minus 1 again 3. Here lambda minus 1, lambda minus 1, and here mu minus 6. Okay, so we have to apply one further row operation such that we can reduce it into the echelon form. So you can see here is 3, here 3, so we have to subtract R3 minus R2, and it's R3 becomes our new row. So let's write here 1, 1, 1, 6 as it is, second row it also as it is, 14, it's 14. Okay, now the third row become here 0, 3 minus 3, 0, here lambda minus 6, and here mu, here minus 6 minus 14 is subtracted from this value, so you get mu minus 20. Now then lambda. Now you can see, we know if the system is inconsistent, then the rank of this matrix, coefficient matrix, must not equal to the rank of this augmented matrix. Okay, this whole matrix and this coefficient matrix has a different rank for system to be inconsistent. So let's, if we make this element, okay, suppose let we make this element is 0 and this element in non-zero, then and then this condition will satisfy. If this element is 0, then we get a rank for the matrix is 2, and if this element is non-zero, then the rank of the A augmented matrix is 3. So we can say that the rank of the coefficient matrix is not equal to the rank of the augmented matrix, so the system has no solution. So for this condition, we have to choose lambda is equal to 6 and mu any value excluding 20. So this is the right combination of these two variables for the system has inconsistency. So we can select answer C. Okay. So option C is the right answer. Okay, let's move to the question 5. Okay. Question 5 says the eigenvalue of the Q symmetric matrix. Okay. Okay. If we, what is the Q symmetric? First of all, it has a property. If we take the transpose of that matrix, it is minus of that matrix. Okay, so this is the property of Q symmetric matrix. Now it also has a property that its are eigenvalues are either zero or imaginary or imaginary. So from the option you can see option C is available. The eigenvalues are either zero or purely imaginary. So option C is the right. Always zero, it is not necessary, and always pure, no, it may be zero. And option D, always real, no, option D is the wrong. So option C is the only correct one. Okay, let's move to the question number 6. Okay, okay, the question 6 says the minimum eigenvalue of the following matrix. Okay, they are asking about the minimum eigenvalue, so we have to solve the characteristic equation of this matrix and equate determinant is equal to 0. From there we get we can get the polynomial in terms of lambda, and we have to solve for the lambda. From there we can get the minimum eigenvalues. So first let's form the determinant. 3 minus lambda, here 5, here 2, here 5, here 12 minus lambda, here 7, here 2, 7, 5 minus lambda. Okay, so now we have to take the determinant and equate is equal to 0. So let's solve uh, here 3 minus lambda in the square bracket. We have to multiply this both term, here minus 4 7 multiplied by 7 49. Okay, this bracket is over. Here the minus 5 as it is. Here we have to exclude this row in this column. We have to multiply this both minus this both. So we get 5 into 5 minus lambda minus this 17. plus we have to write this last term 2 into we have exclude this and multiply this both minus this both, so 35 minus 2 into 12 multiplied by lambda, and we have to equate all equal to 0. So okay, so let's multiply this bracket with this both term. So what are we getting? 3 minus lambda, 12 minus lambda, 5 minus lambda, minus 49 multiplied by 3 minus lambda, minus, let's multiply this 5 with this, then 25 into 5 minus lambda, then lambda minus minus become plus, and here we are getting 17 plus, we are from here 70, let's multiply 2 with this bracket, and here 4 into 12 minus lambda is equal to 0. Okay, now let's multiply this both bracket. So first bracket remain as it is. Let's multiply this 2 minus 5 lambda minus 12 lambda plus lambda square. Okay, let's multiply minus 49 with this bracket, minus 47 minus minus plus 49 lambda. Let's multiply this, 125 minus minus plus 25 lambda. Okay, 70 plus 70, 140. Okay, minus 48 minus minus plus become 4 lambda is equal to 0. Now simplify further. What we are getting? It's lambda square minus 17 lambda plus 60 minus, okay, let's write first this lambda term. So here 49 lambda, here 25, and here 4. So if we add them all, so what we are getting? Okay, 78 lambda, and if we add all this constant term, 147, 125, and 140 and minus 48, so we are end up with minus 180. So 180 is equal to 0. Now let's multiply this bracket with all this term. So what we are getting? 3 lambda square, okay, minus 51 lambda plus 180. Let's multiply lambda minus lambda cube, okay, plus 17 lambda square, okay, minus 60 lambda. If this bottom is remain as it is, plus 78 lambda minus 180 is equal to 0. Now you can see 180 here, from here both are cancelled out. So after that we are getting the equation is lambda cube here, the lambda square term are, one is here and one is here. If we add both them, we get 20 lambda square, and with lambda term minus 51, here minus 60 plus 78, then what we get is minus 51 minus 60 plus 78 is minus 33 lambda. We have to equate is equal to 0. Now we can take the lambda out common, so we get minus lambda square plus 20 lambda minus 30 is equal to 0. Now you can see that the first one of the solution of this equation is lambda is equal to 0. Now you can find the other two values by solving this quadratic equation. Okay, you can solve by using formula like b square minus 4ac by 2a. Okay, from there you can find the other two values of the lambda, but we are interested here in the minimum value. So these both are the larger than the 0 if you find by this equation. So here the correct answer is the 0. Now here you can also uh, do find the determinant of this matrix. If the determinant of this matrix it turn out to be 0, then we can say at least one of its eigenvalue is 0. Okay, either lambda 1 or lambda 2 or lambda 3. Okay, in the option we have non-negative value is given in the option, the 0 is the given. So the from here we can say that if the determinant is 0, then it's one of the eigenvalue must be 0. So you can also select the 0 from this method. But if the negative option is given, then you cannot sure that the either lambda 3 may be minimum if its negative option are the given in the question. Okay, so let's move to the problem 7. Okay, here what they are asking, given we have given matrix A and we have identity matrix 2 cross 2. Okay, they are asking the value of AQ. Okay, uh, uh, we can solve this problem by the using Kelly Hamilton theorem. Okay, but uh, we can, sorry, Hamilton, but here we are trying to solve this problem with different method. So what we are going to do, first let's find the eigenvalues of this matrix A. So what we are getting is minus 5 minus lambda minus 3 remain as it is, here 2 remain as it is, here minus lambda. Let's find the determinant and equate is equal to 0. So what we are getting, minus 5 minus lambda plus 6 is equal to 0. If we expand, multiply it, so it's 5 lambda plus lambda square plus 6 is equal to 0. So you can say lambda square plus 5 lambda plus 6 is equal to 0. Now you can find the values of the lambda, minus 5 plus or minus under root of 25 minus 6 multiplied by 4, 24 divided by 2 into 1. So you can get 5 plus or minus 1 divided by 2. From there you can get the minus 3 and minus 2 as an eigenvalues of A. But now in the question they are asking about the AQ. So we know that if lambda 1 and lambda 2 are the eigenvalues of A, of matrix A, so we can say that lambda 1 cube and lambda 2 is cube, lambda 3 is lambda 2 cube are the eigenvalues of A cube. Okay, this is the one of the properties of the eigenvalues. So what we are going to do, we have to find the eigenvalues of the A3. So we already find the eigenvalues of the A. So we have to just cube it. So we can, let's denote is lambda 1 dash for the A cube. What we get is minus 3 cube is, what we are getting is minus 27. Okay, lambda 2 dash, it's minus 2 cube, it's minus 8. Okay, so we have find out the eigenvalues of the A cube. Now let's check option A, B, C, D. Which option is satisfying? We know eigenvalues of A and we also know the eigenvalues of the identity matrix. It's simply 1 and 1. So we can put the values. Let's first select option A and let take the eigenvalue here, minus 3. So let uh, put it, and what we are getting, it's okay, it's minus 33. So it's not minus 27. So option A is the not correct one. Let's check option B. It's 90. minus 3 plus 30. So you can, yes, you can get minus 27. Okay, let also check for minus 2. 90 multiplied by 90, 90 multiplied by minus 2 plus 30. So you also get minus 8 in the output. So you can see that this both eigenvalues corresponding to the a cube. You can also check option C and D. They will not satisfy this condition. Only option D is the satisfying this condition. So you can directly solve. You can also solve for any power by this method in the very short time by the checking the option. Okay, so here the option B is the correct answer. Okay, let's move to the problem 8. Okay, problem 8 says that a real 4 cross 4 matrix A satisfy the equation. Okay, it's satisfying this equation where I is the 4 cross 4 identity matrix, the positive eigenvalue of the matrix. Okay, now uh, we know from the Cayley Hamilton theorem that every matrix every matrix satisfies its own characteristic characteristic equation. Okay, sorry for the handwriting equation. So here what equation is given in the form of matrix is x s square is equal to I. Now we have to go in the reverse direction. We have to put the lambda for A, and we have to put 1 for the identity matrix. We are going in the reverse direction. So okay, so what we get, the characteristic equation we get from this is like this: lambda square is equal to 1. Okay, so here we can solve for the lambda. So we get lambda is equal to plus or minus 1. So we have done. They are asking about the positive eigenvalue, and we have to write the answer because it is an numerical answer type question. So we have to write the one in the blank. Okay, let's move to the problem 9. Okay, the problem 9 says the determinant of the matrix A is given is 5. The determinant of the matrix B is 40. And the determinant of the matrix is, okay, we have to use the properties of the determinant. One of the properties is that if determinant of, we have to find the determinant of this matrix, which is multiple of this multiplied by this both vector, which are both matrix. So we can simply what we are doing, take the matrix of determinant of matrix A and the determinant of matrix B. We have to simply multiply this both value and we get the determinant of this AB matrix. So here a determinant of A is given already, it is given as 5. Okay, and here B, determinant of B is also given is 40. So here we are getting 200 is the determinant of AB matrix. So they are asking about the determinant of this AB matrix. So we have to write here to 200 because it is again numerical answer type question. Okay, so let's move to the problem number 10. Okay, problem 10. They are saying for the matrix of the same dimension. Okay, m and n has the same dimension and scalar c. Okay, c is any scalar. Which one of this property does not? Okay, they are asking about the which property is does not always true. Okay, so we are going by option. Let's say for option A, if we are taking the transpose of transpose then we know it's again the same matrix, because in the transpose, let's suppose we have 1 2 2 3, then we are taking the transpose, we have to intersect row and column. Now we are taking again transpose, so we are going from this and again from this is a cycle. Okay, if you take the transpose of the transpose, it's again the same matrix. Okay, so option A is the always hold. Let's say option B. Okay, option B says, okay, we are, okay, here C is the scalar, given it is C is any scalar, and there is no any sense to take the transpose of that scalar, so we can take the scalar out and take the transpose of this matrix and multiply with this scalar. It is also the always hold, so option B is also right. Now the option C says, uh, let's we have to find the transpose of this uh, addition of this matrix. So what we can do is take the individual transpose of this matrix and add them. It is also always true for any matrix of the same size. Okay, and now option D says the multiplication of mn is equal to the nm. Now this property is not always hold, not always true. Okay, so even sometime mn is defined, but nm even is not defined, because in multiplication we have one condition, that the number of the column of the first matrix and the number of row of the second matrix must be same for the multiplication. Okay, so sometime we can get mn but not nm, so this property is not always hold, so the statement D is the incorrect. So the our correct answer for this problem is D. Okay, because remaining three are always correct, but option D is not always correct. Okay, thanks for watching.